today's lesson. We want to look at introduction to logarithms for today. Okay, so when we talk about loss, what we are saying is that it's another way of expressing a number of index form. So this is the index form, and we can re-express this in logs. Okay, so in this case, what is happening is that the result, which is the b, is now going to be a log of the b, which is the result, to the base e. And the base e is what we have here, and its power becomes the result. So basically, that is what we are talking about. So it's just another way of expressing index form. Okay, so if this is clear enough, then we can go ahead and solve example 1 to 5. Let's begin. So with the first example, with the same idea, what this means is that this is going to be log to the base 10 of 100, which should be equal to 2. Over here, our power is the result. Our 10 becomes the base, and the result here is our log number. All right, so let us go ahead and solve the second example. The first and the second example, the only difference is that I interchange the positions, but it is the same thing. So over here, this is going to be log of 2, 4, 3, and the base is going to be 3. This is our base, and the result is going to be the power, which is 5. As simple as that. All right, so in a third example, the same thing is the same thing. So what we want to do here is that log, our value here is going to be 1 over 128. The base is 2, and our result is the power that we have, which is negative 7. Okay. In the fourth example, we have 7 raised to the power 0 equals 1. We know that any number raised to the power 0 is 1. This can equally be expressed in the log form. So this would become log 1 base 7 equals 0. The same idea. So the base is 7, and then our power is a 0. So take note of this concept. This actually means that the base, which is our 7, can be any number at all. So the log of 1 to the base any number is always going to be 0. So that means that the log of 1 to the base n is equal to 0. Let me put this in a box. So this is a property of logarithm, and you are going to be applying it in subsequent examples. All right, so for our final example, what we are saying is that 10 raised to the power 1 is equal to 10. Any number raised to the power 1 is equal to the number itself. So over here, in terms of log, this is going to be log 10 of the base 10, this is the base, is equal to 1. So anytime at all we have log to the base 10 of 10 is always going to be equal to 1. Now, it does not only apply to 10, any number at all. So if you have, let's say, 5 raised to the power 1 equals 5, then you can express it as log of 5 base 5 equals 1. So anytime you have the same number as the base, then your results will always be equal to 1. And this is also another property of logarithm, and that can be expressed as log x to the base x, which is always going to be equal to 1. Let me put this also in a box. I hope this helps.